the next part talks about the equations. It gives you an equation that's factored out. And it gives you, when it's all multiplied together, and it gives you the graph of the function. Wow, so they gave you everything. From the graph, we're going to identify the zeros. The zeros are where on the graph? On the x-axis, where it touches or crosses the x-axis. Then synthetically, we're going to divide the expanded form of the function by each factor. Okay. So, let's look at this first. Tell me some zeros. Negative 2, negative 1, and 1. Everybody with me? All right. So negative 2, negative 1, and 1. So we are going to divide by those. Negative 2, I guess I should write those down somewhere. So if I plug in negative 2 into dividing it into that, synthetically divide. Okay, so we want to divide. So I have 1x cubed, 2x squared, minus 1, minus 2. I bring down the 1, multiply, add, multiply, add, multiply, add. That's really all we needed to do. Let's just synthetically divide. We're going to do the same thing with the other ones. Which is negative 1 and 1. 1, 2, negative 1, negative 2. So bring down the 1. That's negative 1, negative 1, and positive 2. I'm doing that kind of fast, but I feel like we've done it a bazillion times at this point. And then the other one was 1. 1, 3, 2. I'm sure you're drawing conclusions, and that's good. Which we're going to put those conclusions into words. But let's do one more, because, you know, it takes more than one to get a row. So let's look at the picture first. Am I going too fast? Okay. Let's look at this picture. You may have to estimate a little. Where are the zeros? Okay, negative 2.5 and 1. Yes, you're right, by the way. Negative 2.5 and 1. So those are my two zeros we're going to plug in here. Okay, so I have 0.4, negative 0.2, negative 1.8, 2.6, and negative 1. Ooh. I'll be totally honest with you, I'm so using a calculator. Okay, negative 2.5 times 0.4 is negative 0.1. Add those together, you get negative 0.3. Oh no, sorry, I typed in the wrong thing. Just kidding. Try this again. There we go. I multiplied 0.25. So negative 2.5, there we go, times 0.4 is -1, which that's -1.2 when I add those together. So -1.2 times -2.5, I get +3. Add those up, I get +1.2. -2.5 times 1.2 should be a -3. So that's -0.4. And -2.5 times -0.4 is +1. Phew. Now the other 0 was a 1. So I have 1 times 0.4 is 0.4. Add those, I get 0.2. 1 times 0.2 is 0.2. Add those, I get -1.6. 1 times -1.6 is -1.6. Add those, I get 1. And 1 times 1 is 1. I get 0. So, what do you notice about the zeros and what you end up with the remainder?
The remainder is 0.
Yes. If it is a 0, if it's where it crosses the x-axis, when you plug it in or you try to synthetically divide, you're always going to end up with a remainder of 0. That's how you know it's a factor. That's how you know when you set it equal to 0 and you get the x-intercept, that's how you know it's the x-intercept. So I'm going to shorten this. The x-intercepts will give us 0 and we divide. Give us 0 for the remainder. Sorry. That's what happens when I think on my feet. So when it is an x-intercept, then I know it's going to give me a remainder of 0 when I try to divide by, or using the remainder theorem, when you plug it in, it should give us 0. And that's the factor theorem. So here's where we're going to write it out in pretty words, what we just figured out. If a polynomial function, is synthetically divided by one of its factors, x minus a, then the remainder must be f of a equals 0. So whether you do synthetic division or you plug it in, you're going to get 0. stop there. Yeah, I will finish this on video, and then that's what y'all will do tomorrow. Finish taking the notes and watching the video while y'all are at home.